So continuing on from the last video, maybe you got a chance to practice these radicals on your own. If I were to simplify these, if I want to take the square root of 27 and simplify that, again, you can make your list of factors of 27 if you're unsure of them. So let's see, we've got 1 and 27. 1 and 27. We've got 2 is not a factor. 3 is a factor. 3 times 9. 4 is not a factor. 5 is not a factor. Nor 6 or 7 or 8 or 9 is a factor, but 9 is already on the list. So that's how you know your list is done. So again, if I cross out all the numbers that are not square, 1 is, 27 is not, 3 is not. My only choice is 9. So I'm going to rewrite the square root of 27 to be the square root of 9 times what gets you back to 27, which is 3. Well, the square root of 9 is 3, right, from the list up top. So you've got to know those square numbers. So then I can, instead of writing it the square root of 9, I can write the number 3 because these two things are equal to each other. And then I still have to tack on that square root of 3 that can't be simplified. It can't come out of the radical because there is no other square number that goes into the number that small. Okay, let's do the square root of 48. 48 has a lot of factors. We've got 1 and 48. It's an even number, so we know 2 goes into it. Particularly, we know that it must go into it 24 times. 3, you can check if that's a factor, and it is. It's an important one. 3 times 16 is 48. 4 is also a factor. It goes into 48 12 times. 5 is not a factor. 6 is a factor. 6 goes into 48 8 times. 7 is not a factor. 8 is a factor, but it's already on the list. So that's how I know my list is done, because I'm getting a repeat of factors that are there. So let me cross out all the numbers that are not square. Hopefully you've maybe realized by now that 1 doesn't ever help us, right? Because when you divide something by 1, you're not really simplifying it anyway. So you'll never use the number 1 here, even though it is square. 48 is not square. 2 is not. 24 is not. 3 is not. 16 is. 4 is. 12 is not. 6 is not. 8 is not. So step 2 says determine what is the largest square number. That is important. If you choose 4 instead of 16, you're going to simplify it, but then you're going to have to redo the whole process again. So choosing the largest square number lets you get to the answer quicker, I'll say. So the square root of 48 can be rewritten as the square root of 16 times the square root of 3. Well, the square root of 16 is a square number. Its square root is 4. So instead of the square root of 16, that equivalent number is 4. So these two things are equal. And then we're still going to have to leave our square root of 3 tacked because we cannot simplify that part further. Okay, then we got the square root of 72. Now another way, instead of writing out all the factors, something else you could do is if you go up here and you look at your list of square numbers, you realize 72 isn't on the list, right? But if it were on the list, it would be somewhere in this range, right? Because there's 64, so it'd be here. So what you can do is, you know, none of the square numbers bigger than 8 could be a factor, right? 9 can't be a factor of 72 because it does not go into 72 evenly, because then you get bigger numbers like 81, 100, 121. So you know you can't use any numbers bigger than 8. So start with 8 and just check in your calculator, do 72 divided by 8. Well, then you get 9. So that's good, but that means 8's not exactly a square number. Well, I'm sorry, 8's not the square number. I shouldn't be dividing by 8. I take all that back. Divide 72 divided by 64. 64 is the square number in this scenario. So 72 divided by 64 is 1.125. So that doesn't go in evenly. So 64 doesn't work. So go to your next one. Go to 49. 72 divided by 49. Is that a square number that goes in evenly? No, because then you get 1.4693, blah, 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 blah. So 49 doesn't go into 72. So try the next one on the list. Try 36. Well, 72 divided by 36 is 2. That's great news. That means 36, which is a square number, goes into 72 evenly, particularly. So then we can have the square root of 36. It goes into that twice. So the square root of 36 times the square root of 2. Now the square root of 36 is 6. So then this can reduce to be 6 square roots of 2. And the last one, number 4, the square root of 75. Hopefully you kind of also get more comfortable with your numbers and which ones are factors of what others. A number ending in 5, that should always kind of pique your interest as to the number 25. And 25 is a square number, and it does indeed go into 75, right? Think money. 25 cents goes into 75 cents 3 times. So the square root of 75 can be broken up into the square root of 25 times the square root of 3. The square root of 25 is 5. So our final answer could be 5 square roots of 3. So hopefully that helps you understand how to simplify radicals. It's a skill that we're definitely going to need moving forward when we use the Pythagorean theorem. If you're still kind of struggling a little bit, this video is on YouTube, so you can go watch it again, or you could find another video. I highly recommend Khan Academy videos because those are amazing. And just go listen to somebody else explain how to do it. There are other ways that you could approach simplifying square roots. This one I found has worked the best in the past. But maybe hearing somebody else say things a little bit differently will help you understand a little bit more. But hopefully this was gave you a pretty good understanding, and moving forward you're comfortable with simplifying radicals.